Hi guys, this what you see is a microwave transformer. You can see that here it is written class 230 volts 50 hertz. Okay, and what more you can see here is that there is no secondary winding and only this thick primary winding. And of course these are the two terminals with which 220 volt supply will be given to this. Now I used this transformer in a few of my previous videos, like making a high current power supply, a spot welding machine, etc. So here in this video I'm going to give you a few basics on this. Plus I'm going to make a very powerful electromagnet with this microwave transformer. So guys, this is a 24 volts variable power supply DC voltage adapter, and at the back of it you can see output DC 9 volts to 24 volts at 3 amperes, input voltage 100 to 240, 50 to 60 hertz. So I'm going to use this power supply to show you one effect of this microwave transformer with a DC input source. Okay, so let's do that. So guys, these are the two terminals coming out from this power supply. Now when I will touch this, you will see that the voltage indicated here will go to 0 because of the maximum voltage drop. Now you will also see the sparking, very little, almost zero spark, yeah, very less. But you see this thick coil and this transformer is totally closed. The magnet circuit is completely closed. So I will connect one terminal over here, and when I will connect the other terminal like this, there will be no effect. But when I will release the terminal, there will be a huge spark because of the stored magnetic field in these copper wires. Now I will give you a closer view. Okay, so I have turned off the lights. Now guys, the spark was so high that the voltage was in thousands of volts and not just 9 volts that I fed through this power supply. Voltage from the output of the inductor is always very high, and that's why it easily fills the gap between the terminals even though the terminal gets disconnected. Now this was about the inductive effect. Now guys, at present the magnetic circuit is closed because of this bar. So if I will cut this bar with the help of an angle grinder and open it, it will become an E-shaped object like this and this, and it can be used as a very powerful electromagnet. So the first part is cutting the head off. Okay. So guys, as you already know that this was a microwave transformer, you can see that I have given a cut, a full cut on this side and on this side. You can see there is a full cut. So this, what happens because of this cut is that when the cut is closed, then the magnetic circuit is also closed. And that type of setup is used in a transformer, a closed magnetic circuit for maximum magnetic induction in the other coil, secondary coil. But when we are making an electromagnet, then we need a half cut for a secondary metallic object to close the magnetic circuit, and that's how it is going to stick to the electromagnet. So guys, taking an example of this metal piece. Now initially when this was closed, then this metal piece would not have stuck to the head of this transformer because the magnetic circuit was fully closed and no magnetic field was getting out of these poles. Okay, but when I'm going to place it like this, then the magnetic field is going to use the only path that is available for it to transfer the magnetic field, which is going to be this metal through this metal. Okay, so this pole, then this pole. So one pole, main pole will be this, and the other pole will be these two, half on this and half on this, and this is how it becomes an E-shaped magnet. Not a powerful U-shaped but an E-shaped magnet. These two together make one pole, and this single makes one large pole, north and south, or north and one south. Now guys, this is a power supply 220 volts up to 12 or 15 volts with a maximum current of up to 17 amperes. This is the voltage that is being displayed here, 14.5 at present. The link for this will be available in the description. I'm going to use this power supply to charge this electromagnet. So you can see I have used 2 thick copper wires because I need high current to flow through that supply. Connecting one terminal like this. Now when I will connect the other terminal, this coil will charge and this will become an electromagnet. Okay, it has charged. Now when I will remove this, you can see the spark, which is because of the inductance effect, which I already showed you a moment back. Now this is the metal piece that I was talking about before. Let's keep it like this, a little up on this transformer. You see? Now it is very difficult to pull it. I have to remove this to pull it up because the current flowing through this charges it to a very powerful electromagnet. Okay, so guys, let's remove this from this metal base. So guys, because half of the magnetic circuit is being completed because of this and this, so I will remove these so that the overall strength of the magnetic circuit gets on these 3 parts. Okay. So let's throw these away. Okay, so let's remove this part. So guys, as you can see, the coil is out of the transformer. Now what I will have to do is weld this part to this core on the sides. The coil is very nice. I can also use it to make a very powerful electric generator. Yeah, well, maybe in one of my future videos. Let's make what I'm going to make at present. So guys, as you can see that I've hammered the coil little upwards than it was before, so that I can give a little weld on this spot. So guys, this, as you can see, is the final electromagnet. I have connected 2 wires for ease of connection, and this is the rod for holding it better. I have welded it to this transformer. Now this is the power supply, 14.5 volts, as you can see. This is what I'm going to use to power this up. So let's see if this power supply is strong enough to power this electromagnet and pull this weight. So guys, I think here you can see that it is showing 20 kgs. So let's try and pull this with this electromagnet. So guys, you can see that everything is set now. All I have to do is turn on the supply and the magnet should start. Yeah, the supply has been turned on. Let's stick it to this and see. The magnet is not formed yet. Some wiring problem, I guess. Yeah, there was sparking. I think it's working now. Yeah, it is working. Let's try and pick it up. Whoa! So guys, as you can see that it is easily pulling up this 20 kgs weight. Yeah, the magnet is very strong. It's not letting it go. Let's turn off the supply. And guys, now that I've turned off the supply, it should be easily removable. Yeah, you can see that now it is not sticking. Hi, this what you see is a computer UPS transformer, 220 volts to 12 volts. And here what we have is our 220 volts AC supply from home socket. See, so these are the two jumper wires that I'm going to connect to the power supply and to the transformer, and then it is going to produce 12 volts. So guys, your hidden question for today is, how many watts solar panel did I use to test my MPPT in my previous video? And now simply connect this wire. A transformer has high voltage and low voltage sides. Always make sure that you know which one is high voltage and which one is low voltage before connecting it directly to the power supply. Now guys, here as you can see are three UPS transformers. This one is not working, it's dead, although these two are working. Now here I'm going to tell you an easiest way and the safest way to find out which one of them is working and which one is not working, which is the series connection with this bulb. Now this is, you see, 220 volts AC supply source, and these are 3 pins, one for earth. And the transformer has high voltage side represented by thin wires and low voltage high current by thick wires. Take one of the thin wires and connect it to the bulb in series. Done. Now 2 wires remain, one from the bulb and other from the transformer itself. Bulb wire connected, and yeah, no current because the switch is turned off. And here we are, done. Now let's turn it on. You see, it's not glowing. Now let's turn it off and connect the bad transformer. Yeah, connected. Let's turn it on. You see, this time the bulb is glowing. It's really dim, but still it is glowing. Now here you can see it clearly that it is glowing. I've turned off all the lights. So bulb glowing when connected in series with the transformer and no load connected indicates it's dead. The transformer is dead. But if the bulb would not have been glowing, then it would not be dead. It would be perfect, because at no load, transformer draws almost zero current. Now this what you see is a metal rod, and what I'm going to do is short it, and now it is drawing even more current because initially it was lightly loaded because of some internal fault, and now I am loading it even more by shorting maximum current flow. So guys, here I'm making some markings so that I can cut it from these two parts. Many of you might already be familiar with the hacksaw that I made in one of my previous videos. If not, link is provided in the description. I'm going to use the same hacksaw to cut off the core of my transformer. So guys, here as you can see, I've made the cut, and that should be enough. Now there is this part that is coming out. I will have to compress it with the help of a C-clamp. So guys, my electromagnet is finally complete. You see, pretty good, right? I've also placed a handle over here to hold it easily, and it's not that big, easy to hold, and also not very heavy because it is made from UPS transformer, but still it is very powerful. Now for testing, I have this spanner and that's the electromagnet. Now the transformer has two windings, primary and secondary. I am going to connect DC supply only to the high voltage side and not to the low voltage side, because to activate the low voltage side we need really high current. So number of turns and high voltage and less current is the priority. I'm going to use my 12 volt supply, 12 volts, 5 amperes, and let's see its power. Okay, holding it like this. Yeah, like this. It's activated, and yeah, it is picking it up. See? Yeah. So with 12 volt supply it's weak. Let's connect it to full power 50 volt supply from my e-bike charger. So guys, this one is my e-bike charger. It has 59 volts plus minus 0.5. Output current is 2.7 amps. So let's turn it on like this. You see, now the electromagnetic strength is really high. And you see the spark? That is high voltage plasma, because this transformer contains large number of turns, which creates really high inductance, and that creates much higher voltage. So it is very dangerous because the overall voltage between the spark gap is much more than 60 volts. Now when I connect this terminal, you will see the current that this electromagnet is drawing from the power supply. It is around 2.5 amperes. Now guys, I have this super heavy Honda generator core, 1000 watts core. Let's activate my electromagnet. Yeah, it's active. It's stuck. Let's pick it up. You see, it is easily picking it up. It's really heavy. Very strong electromagnet. And let's remove it. Now let's move on to even higher weight. Okay, it's stuck. Oh. It is really difficult to pick it up from here, most with one hand. Yeah. You see, it is really strong. Okay. You see, considering the size of this electromagnet, it is very powerful. Easily. Yeah, now I'm tired. So guys, this what you see is a transformer, and I have shown only one winding, and here no cut has been provided to the magnet core. So the magnetic circuit is fully complete and there is no breakage, so it is concentrated throughout the core and not outside. Now what happens if we break that magnetic circuit? Let's say, as I did, we give a cut over here, okay, and over here. Yeah. So after we have given cut over here, it is something like this, this and this. Now the magnetic core is broken from this point and this point, because of which this coil is creating an electromagnet if we give it DC supply. Let's say we give it DC supply 50 volts, here positive and here negative, 50 volts as I did. So for example, we get north pole over here and south pole over here, okay, and this is broken, so the circuit is not complete, so this part will remain north. The flux is going to jump from this point here like this and here. Why? Because the lower part is south, so this also becomes south and this also becomes south. Yeah. And hence north, this giant middle portion is north and these sides are south, and hence turning it into a really strong electromagnet. And this technique can be applied to any transformer, Here what you see is a 48 volts battery pack that is made from 12 volts 4 7Ah UPS batteries connected in series. Here you can see two of them connected in series and one is still not connected. So I'm going to connect this one too in series, and then the final output will be used to make an arc welding machine. So first let's measure the voltage of each battery individually. Pointing multimeter towards 20 volts DC mode, 2 pins black and red. So battery is fully charged at 12.25 volts. Here it is 12.25. Here it is again 12.28, even more, and this is 12.3738. So highest, a little low, and the lowest. Okay. So guys, as can be seen, all the batteries have been connected in series. It's time to measure the overall voltage, and for that I'm going to point the meter towards 200 volts DC mode, because the voltage is going to be more than 20 volts since the batteries are in series. So positive is going to be this side and negative on this side, and here as you can see the display is flashing 49.3 volts DC. Pretty good, right? So let's connect it to the welding cables. So guys, here as you can see that the electrode terminals have been connected, one to positive and the other one to negative. So let's test the machine if it works or not. Okay, so guys, now I'm going to connect the wires, and I'm going to do or try some welding on this, like if the rod melts with this much current and voltage. Okay, so let's do this, guys. Wow, so guys, here as you can see, one of the terminal of the battery is completely gone. So I suppose this was not a good idea for a 7Ah battery, since the terminals are not that thick to carry such huge amount of currents. So guys, as you can see that this battery terminal got destroyed and it is heating up really bad. So I'm going to switch to just 2 batteries instead of 4. So now I'm going to connect the electrode terminals to this battery and this battery, and the remaining 2 will be left open. So let's do that. So guys, let's see if it works with just 2 batteries and with a 24 volt setup, of course. Okay, so let's do this, guys. So guys, here as you can see that it worked with 2 batteries. It is pretty hot and I touched it. So yeah, my hair is going to get a little rubby afterwards. So the welding worked. The important part is you can see the weld So guys, this is what I did to the previous transformer for making a spot welding machine for 18650 lithium ion battery. Now this is the welding machine wire. Although the number of turns are very less, so the voltage was only 1 volt, because of which the current was very high, although but it was not possible to make an arc welding machine with it. So guys, before we proceed with the rewinding procedure, let's do some test with the high current flow. So guys, everything is well connected. All I have to do is press the switch and whatever is going to happen will start happening. Okay, so let's start. So guys, now I'm going to try the same with this welding rod. So this proves that some more voltage is needed to maximize the current flow through the rod. So guys, here as you can see that the secondary winding has been completed, and I have given around 15 turns of this 4 mm copper wire. So let's connect the input supply and check the voltage it is converting. So guys, the primary winding has been successfully connected. Let's turn the switch on and you will hear some hissing sound. Okay, yeah, now let's strip these wires. Okay, so guys, since the output is going to be AC, so I will move the pointer towards 200 volts AC mode. Okay, putting it over here. So guys, the wires have been connected. Let's turn this on and see the voltage. Wow, it's 14.4 volts. That's pretty good for battery charging, I guess. Perfect battery charging voltage. But anyways, at present the project is the welding machine, so let's proceed with that. Okay, so guys, here as you can see that I have connected the welding cables to the secondary winding of this microwave oven transformer, and the switch is right now on, although the main lines are not connected to it right now. So guys, now I'm going to turn off the switch and connect main supply to the transformer. The main supply has been connected. Let's turn it on and see if it works. Yeah, it is working. It is vibrating. So this is the metal piece on which I'm going to do some welding. Let's hope it works. So guys, turning it on now. Okay, so guys, now I'm going to try and weld these two bolts together. Okay, so let's try that.